When powering a guest house from electrical panels located in a separate structure like a garden shed, establishing a proper grounding system is essential for safety and to comply with electrical codes. This involves several key steps. Firstly, establish a grounding electrode system at the guest house. This typically involves driving a minimum of 2 8-foot ground rods spaced at least 6 feet apart. The purpose of these ground rods is to provide a direct connection to the earth, which helps to stabilize voltage and provide a path for fault current to flow back to the source, tripping a breaker or fuse in the event of a ground fault. Connect the ground rods together with a bare copper conductor of sufficient size. Typically, a number 6 American wire gauge or larger copper conductor is used for this purpose. The conductor should be securely fastened to each ground rod using approved grounding clamps to ensure a low resistance connection. Alternatively, you could create a grounding electrode system grounding ring around the guest house using bare copper wire or plate. This grounding ring encircles the structure and provides a more comprehensive grounding path. Secondly, run a grounding conductor to the guest house. This involves running a bare copper grounding conductor of sufficient size, typically number 8 American wire gauge or larger, from the garden shed to the guest house. The size of the grounding conductor should be determined based on the size of the circuit conductors feeding the guest house, in accordance with the National Electrical Code. Connect the grounding conductor to the grounding electrode system at the guest house using a copper ground rod clamp or an approved grounding connector. Ensure the connection is secure and corrosion resistant. Thirdly, ground the electrical panels and appliances in the guest house. Install the grounding busbar in each electrical panel in the guest house. This busbar serves as the central point for all grounding connections within the panel. Connect the grounding busbar to the grounding conductor from the garden shed. This provides a direct path for fault current to flow back to the source. Ground all electrical devices in the guest house, including lighting fixtures, receptacles, and heating, ventilation, and air conditioning equipment, to the grounding busbar. This ensures that all metal parts of these devices are at ground potential, minimizing the risk of electric shock. Fourthly, bond the guest house to the electrical service. Bond the grounding busbar in the guest house to the neutral busbar in the garden shed main electrical panel using a copper bonding conductor, typically number 8 American wire gauge or larger. The size of the bonding conductor should be determined based on the size of the service conductors feeding the garden shed. This bonding connection ensures that the guest house and the garden shed are at the same electrical potential, minimizing the risk of voltage differences between the two structures. Fifthly, install a service disconnect at the guest house. Install a shunt trip push-button service disconnect on the exterior of the guest house. This disconnect allows for the power to the guest house to be quickly and easily shut off in the event of an emergency. Connect the incoming power conductors from the garden shed to the service disconnect. Ensure that the connections are tight and properly insulated. Connect the grounding conductor from the garden shed to the grounding busbar in the guest house. This provides a direct path for fault current to flow back to the source. Several additional considerations should be taken into account. Ensure that the circuit conductors hot, neutral, and ground from the garden shed panels to the guest house are adequately sized for the load. This is crucial for preventing voltage drop and overheating. The size of the conductors should be determined based on the anticipated load of the guest house, in accordance with the National Electrical Code. Consider installing surge protection devices at the guest house to protect against voltage spikes. Surge protection devices can help to protect sensitive electronic equipment from damage caused by lightning strikes or other voltage surges. Label all electrical components, panels, disconnects, etc. clearly for easy identification. This will help to ensure that anyone working on the electrical system can quickly and easily identify the various components. The grounding electrode system should comply with the National Electrical Code Article 250. The size of the grounding electrode conductor should comply with the National Electrical Code Table 250.66. The bonding jumper should comply with National Electrical Code 250.102. When dealing with multiple buildings, the National Electrical Code addresses specific requirements in Article 250.32 focusing on ensuring a safe and effective ground fault current path. This section emphasizes the necessity of either running an equipment grounding conductor with the supply conductors or establishing a local grounding electrode system at the detached building. The choice depends on factors like the presence of metallic water piping and the specific conditions of the installation. Installing a grounding electrode system at the detached building, as previously detailed, involves driving ground rods or installing other approved electrodes. The equipment grounding conductor, when run with the supply, must be sized according to National Electrical Code Table 250.122, ensuring it can safely carry fault current back to the source. Bonding requirements are also crucial. All metal parts that are likely to become energized must be bonded together and connected to the grounding electrode system or the equipment grounding conductor. This includes metal water pipes, gas pipes, and any exposed structural metal. The size of the bonding jumpers must comply with National Electrical Code 250.102. The service disconnect at the guest house is important for safety and maintenance. The National Electrical Code requires a readily accessible disconnect means capable of disconnecting all ungrounded conductors. In this case, a shunt trip push-button service disconnect offers a convenient way to quickly de-energize the entire guest house electrical system in an emergency. The shunt trip mechanism allows for remote operation of the disconnect, which can be particularly useful in situations where the disconnect is not easily accessible. The requirements for wiring methods and materials must also be considered. All wiring must be installed in accordance with the National Electrical Code, using approved methods and materials. Underground wiring must be protected from physical damage, and all connections must be made in approved enclosures. When running conductors between the garden shed and the guest house, it is important to consider the effects of voltage drop. Voltage drop can cause lights to dim, motors to run inefficiently, and other electrical equipment to malfunction. To minimize voltage drop, it is important to use conductors of sufficient size and to keep the length of the run as short as possible. The National Electrical Code provides guidelines for calculating voltage drop and selecting conductors of the appropriate size. The specific requirements for grounding and bonding can vary depending on the local electrical code. It is important to consult with the local electrical inspector to ensure that the installation complies with all applicable requirements. A licensed electrician can provide valuable assistance in designing and installing the electrical system for the guest house. A licensed electrician will be familiar with the National Electrical Code and the local electrical code, and will be able to ensure that the installation is safe and compliant. The electrical inspector will inspect the installation to ensure that it complies with the National Electrical Code and the local electrical code. It is important to schedule an inspection before energizing the electrical system. The National Electrical Code, often abbreviated as NEC, is a widely adopted code in the United States for the safe installation of electrical wiring and equipment. It is part of the National Fire Code series published by the National Fire Protection Association, commonly known as NFPA. While not law itself, the NEC is often adopted by state and local jurisdictions in the United States in law. The NEC covers a wide range of electrical topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is updated every 3 years to reflect changes in technology and industry practices. The purpose of the NEC is to protect people and property from electrical hazards. It provides a set of minimum safety standards for electrical installations. Compliance with the NEC is essential for ensuring the safe operation of electrical systems. Article 100 of the NEC provides definitions for many of the terms used in the code. It is important to understand these definitions in order to properly interpret the NEC. Article 110 of the NEC covers the general requirements for electrical installation. It includes requirements for working space, access, and guarding of electrical equipment. Article 200 of the NEC covers the use and identification of grounded conductors. It includes requirements for the color coding of grounded conductors and the location of grounding connections. Article 210 of the NEC covers branch circuits. It includes requirements for the number and type of outlets on a branch circuit, as well as the overcurrent protection requirements for branch circuits. Article 215 of the NEC covers feeders. It includes requirements for the size and overcurrent protection of feeders. Article 220 of the NEC covers branch circuit, feeder, and service calculations. It provides methods for calculating the load on an electrical system. Article 230 of the NEC covers services. It includes requirements for the size and type of service entrance conductors, as well as the location of the service disconnect. Article 240 of the NEC covers overcurrent protection. It includes requirements for fuses and circuit breakers, as well as the location and sizing of overcurrent protection devices. Article 250 of the NEC covers grounding and bonding. It includes requirements for the grounding of electrical systems and equipment, as well as the bonding of metal parts. Article 300 of the NEC covers wiring methods. It includes requirements for the installation of various types of wiring, such as cable, conduit, and raceway. Article 310 of the NEC covers conductors for general wiring. It includes requirements for the ampacity and insulation of conductors. Article 400 of the NEC covers flexible cords and cables. It includes requirements for the use and installation of flexible cords and cables. Article 406 of the NEC covers receptacles, cord connectors, and attachment plugs. It includes requirements for the type and location of receptacles, as well as the grounding requirements for receptacles. Article 408 of the NEC covers switchboards and panel boards. It includes requirements for the construction and installation of switchboards and panel boards. Article 430 of the NEC covers motors, motor circuits, and controllers. It includes requirements for the overcurrent protection and control of motors. Article 440 of the NEC covers air conditioning and refrigerating equipment. It includes requirements for the wiring and overcurrent protection of air conditioning and refrigerating equipment. Article 500 of the NEC covers hazardous locations. It includes requirements for the installation of electrical equipment in locations where flammable gases, vapors, or dust may be present. Article 517 of the NEC covers healthcare facilities. It includes requirements for the electrical systems in hospitals, nursing homes, and other healthcare facilities. Article 547 of the NEC covers agricultural buildings. It includes requirements for the electrical systems in barns, stables, and other agricultural buildings. Article 550 of the NEC covers mobile homes, manufactured homes, and mobile home parks. It includes requirements for the electrical systems in mobile homes, manufactured homes, and mobile home parks. Article 600 of the NEC covers electric signs and outline lighting. It includes requirements for the wiring and installation of electric signs and outline lighting. Article 625 of the NEC covers electric vehicle charging systems. It includes requirements for the wiring and installation of electric vehicle charging systems. Article 680 of the NEC covers swimming pools, fountains, and similar installations. It includes requirements for the electrical systems in swimming pools, fountains, and similar installations. Article 690 of the NEC covers solar photovoltaic systems. It includes requirements for the wiring and installation of solar photovoltaic systems. Article 700 of the NEC covers emergency systems. It includes requirements for the electrical systems that provide power during a power outage. Article 701 of the NEC covers legally required standby systems. It includes requirements for the electrical systems that are required by law to provide power during a power outage. Article 702 of the NEC covers optional standby systems. It includes requirements for the electrical systems that are installed to provide power during a power outage but are not required by law. Article 705 of the NEC covers interconnected electric power production sources. It includes requirements for the interconnection of electric power production sources, such as solar photovoltaic systems and wind turbines, with the utility grid. Article 725 of the NEC covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. It includes requirements for the wiring and overcurrent protection of these circuits. Article 760 of the NEC covers fire alarm systems. It includes requirements for the wiring and installation of fire alarm systems. Article 770 of the NEC covers optical fiber cables and raceways. It includes requirements for the installation of optical fiber cables and raceways. Article 800 of the NEC covers communication circuits. It includes requirements for the wiring and installation of communication circuits, such as telephone and data networks. Article 810 of the NEC covers radio and television equipment. It includes requirements for the wiring and grounding of radio and television equipment. Article 820 of the NEC covers community antenna television and radio distribution systems. It includes requirements for the wiring and grounding of community antenna television and radio distribution systems. Article 830 of the NEC covers network power broadband communications systems. It includes requirements for the wiring and grounding of network power broadband communications systems. Article 840 of the NEC covers premises-powered broadband communications systems. It includes requirements for the wiring and grounding of premises-powered broadband communications systems. These articles of the National Electrical Code provide a comprehensive set of rules for the safe installation of electrical wiring and equipment. The grounding electrode system helps stabilize voltage. Grounding ensures a path for fault current. A grounding busbar simplifies connections. Bonding equalizes potential. Surge protection prevents damage. Proper labeling aids identification.